Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the database design concepts, and the same chapter, that is chapter number there is the new chapter, that is chapter number 23, that is the XML. In the last class we have finished with chapter number 22. Now I am going to start with the new chapter, that is chapter number 23, that is the XML, that is the extensible markup language. This is the advanced version of the HTML, and in this we're going to study the what are the various advanced feature of the HTML and why there is a need of the HTML. So let's start with this chapter, that is chapter number 23, and this is one of the important chapter that is a part of the database management system, that is the XML. So let's start with the chapter number 23, that is the XML, that is extensible markup language. So let's start with the chapter number 23. So this is XML that was not designed for the database application. In fact, the HTML on which the World Wide Web is based, XML has its root in document management. So whatever the root, whatever the content, whatever the criteria that is used, that is available in the HTML, or we can say this is the advanced, or XML is the advanced version of the HTML that we are used for using the World Wide Web, that is based on the World Wide Web. XML has its roots in document management and is derived from a language for structuring large document known as the HTML, that is a standard generalized markup language, that is a standard generalized markup language, that is a HTML. However, unlike HTML and the XML or HTML, XML is designed to represent the data. So whatever the data is available, that is designed to form the database management system, that is designed to make the database management system. So in particular, it is useful as a data format, or XML is used as a useful data format when an application must communicate with another application. So whenever application communicate with another application or integrate with another application, that is used to with various application, that is used with various features of the XML, that is features of the HTML. When XML is used in these contents or context, many database arise or many database issues arise. That includes how to organize, manipulate, and query the XML data. That is how to organize the data, how to manipulate the data, and how to query the XML data. In this chapter, we introduce XML, that is what is XML and how to use the XML, and discuss the management of the XML data, that is how to maintain the database management system that is used for the database techniques and the exchange of data format that is used as a XML document. So whenever we use the HTML and whenever we use the XML, XML is the advanced part of the HTML, that is line concept that is used in the XML format, that is a database technique that is used for exchanging the data that is available in the XML format. So whenever we want to exchange the data, that is whenever we want to integrate the data, exchange the data between the XML document that is available in the XML documents. Now, what is the main motivation? What is the main motto of the XML, or what is the main motto of using the XML? So to understand XML, it is important to understand its root as a document markup language. The term markup refers to anything in a document that is not intended to a part of the printed document. So markup means the rules and the regulation that is used, or the we can say the rules that we follow in the XML, that the rules that we follow in the document that is not intended to a part of the printed output. So whatever the printed output, whatever the content that is used, that is not a part of the printed output, that is the markup. For example, a writer creating a text that will eventually be typeset in a magazine may want to make notes about how the typesetting is used, or how the we can say the how to make the writer, or how to adjust the typewriter so that the typing is very good, or we can say the typing is accurate, and we must maintain the typing in an accurate speed. It would be more important to type these notes in a way so that they can be differentiate from the actual content. So that is a whenever we type something, so that should be proper formatted, or that should be in a proper formatting to use as a note, to use as a we can say the word that is used in a various print, that is used in a various content that is available in the database management system. So such notes convey extra information about the text, and in the electronic document processing, a markup language is a formal description of what part of the document is content. That is, what part of the document is content, or what part is available as a content, and what part is not available as a content. That is a XML, that is a standard markup or extensible markup language. So extensive or markup language is a formal description of what part of document is a content, what part is markup, and what the markup means. That is a what is a document talks about. what part is available for the markup and what the markup means, that is what is the meaning of the markup that is available in the database management system. That is the main motto, that is why there is a need for the motivation, why there is a need for the content of the motivation. Just as database system evolved from physical file processing to provide a separate logical flow, markup languages evolved from specifying the instructions, that is how to print parts of the document, to specify the function of the content. For example, with functional markup, text formatting or the text representing the section headings, for example, the word motivation would be marked up being a section heading instead of being marked up so as to print the text in a large size bold font. And from the viewpoint of the typesetting, such functional markup allows the document to be, that is a markup language that is used to allow the document to be formatted differently in a different situation. So whatever the situation, whatever the scenario that is used, so it is used in the, or XML is used in the different format, it is used in the different criteria. It also helps different part of the large document or different pages in a large website that is to be formatted in a uniform manner. So whatever the document, whatever the large site, whatever the, we can say, the website that is available, whatever the pages that is available, that is formatted in a uniform manner. More importantly, functional markup also helps record what each part of the text represents semantically. That is, whatever the record, whatever the data that is available, that is how to represent them in a systematic way, semantic way, and corresponding help automate extraction of the key parts of the document. That is, how to use them, how to automate the extraction of that part of the document. For the family of markup languages, so whatever the markup languages that is available, that includes the HTML, that includes the SGML, that includes the XML. So the markup language is also available, that is also used, that is for a family of the markup languages, that includes the XML, that includes the HTML, that includes the SGML. And the markup takes a form of tags. So whenever we use a markup language that takes the form of the tag, that is enclosed in an angle bracket, that is enclosed in a left angle bracket and the right angle bracket. And tags are also usually used in a pair, that is a tag, and there will be a closing tag that is used in the markup language. So this is the opening tag, this is used, this is the closing tag, this is used. That delimitates the beginning and the end of the portion of the document to which the tag refers. For example, the title of the document might be represented as follows. So this is the title that is used, and this is the content of the title. So whatever the title or whatever the content that is available in the title, that is given in this content, and the title will be closed. That is the title, then this is the content, this is the title, closed. Unlike HTML, XML does not prescribe the set of tags allowed, and the set may be chosen as needed by each application. So whatever the tags, whatever the data that is available, that must be chosen as needed by the application that will be used to describe or prescribe the tags, that is a set of the tags. This feature is a key to XML major role in data representation and exchange. That is, the XML is this is the main role of using the XML as compared to the HTML. That is the data representation and the exchange. So there will be a more demand, there will be more clarity in the data representation and the exchange. Whereas the HTML is used primarily for the document formatting. Now this is used as a university, then department name, computer science, then department name, closed. Then there is a building, then there is a tailor, then there is a building that is also closed, then budget, then this is a 1 lakh, or we can say the 10 lakh or 1 lakh, then this is the budget is also closed, then the department is closed. So this is the one part. Now again, in university this is one department, then in the next department, the department name is biology and the building name is Watson and the budget is 90,000, and department is also closed. Now next, what is the course or various courses that is available in the HTML? That is a course, then there is a course ID, this is a course ID, then title, this is the title of the course, then there is the department name, that is a computer science, then there is the credits, that is how many credits are available, that is 4, then the course is also closed. Then again the new course will be used, then course ID, then again title, then department name, then the credit. This course is also closed. Now this is the XML that represented a part of the university information. Then there is a who is the instructor that is available in the university. This is the ID of the instructor, this is the name of the instructor, this is the department name of the instructor in which the instructor is working, then this is the salary of the instructor. Then the instructor will also be closed, then again the instructor, then ID, then this is the ID of the instructor, then name, band name, department name, computer science, then salary 92,000. Then again the instructor, then ID, then name of the instructor, that is a Craig. Then again it is closed. Then next category is teaches or teachers, or we can say what are the teacher that is available in the university. The first ID or the first element is ID, then course ID, then teaches, then again ID, then course ID, that is which course is taken by the teacher, then again the course ID. So this is the continuation of the figure 2.8, that is information about the teacher, about the subject, about the course, about the content, about the ID or about the instructor, that is also available in this example. For example, in a running university application department, course and instructor information can be represented as a part of the XML document. So whatever the information, whatever the content that is available, so this will be shown in the figure, this two figures that is available in the XML document. Observe the use of the tags such as the department, course, instructor and the teaches. So there are four tags that is available. One is the opening tag, one is the closing tag. And the name of the tag that is used is the department. That is a department, then there will be a course, then instructor and the teacher. So these are the four elements that is available or that is a part of the university. Then to keep the example short, we use a simplified version of the university schema that ignores section information for courses. We also use the tag ID to ignore or to denote the identifier of the instructor for reasons as we see or as shall see later. The tags or these tags provide context for each value and allows the semantic of the values to be identified. That is, whatever the tag that is used, whatever the value that is used, so every tag is identifying some value and allows the semantic of the values to be identified. That is the identification of the value that is available in the tags. For this example, the XML data representation does not provide any significant benefit over the traditional data representation. So the XML document does not provide any data representation that is available in the traditional relational database or data representation. However, we can use this example as a running example because of its simplicity. This is another example, that is a purchase order, then identifier, then P101, then again identifier, then again purchaser, that is the name of the purchaser, then name, then address of the purchaser, then the purchaser is closed, then again the supplier name, supplier address, then supplier is closed, then there will be item list, that is a purchase order item list, then there will be item, then item identifier, description, quantity, price, then the item will be closed, then again the item, there is an identifier of the item, then the item again will be closed, then there will be total cost, that is the total cost of the money, then payment terms, that is cash on delivery, then shipping mode, that is what is the shipping mode, that is a 1 second or delivery, then this is the purchase order, that is the XML representation of the purchase order, that is how many items are required, who is the supplier, who is the purchaser, and what are the various item list, and what is the cost of the item, and payment, what is the payment mode of the item, that is either cash on delivery or either using the first hand delivery or first second delivery. So figure 23.3 shows how information about a purchase order can be represented in the HTML, illustrates a more realistic use of the XML. And compared to the storage of the data in the relational database or relational model, some representation may be inefficient since tag names are repeated throughout the document. So as compared to the relational, XML has some loopholes, has some bugs, that is it will be used to represent the data, it will be used to represent the information that may be insufficient to store the data since tag names are repeated throughout the document. So this is a very common trend, that is the tags are repeated throughout the document. However, in spite of this limitation, an XML representation has significant advantages when it is used to exchange the data. So this is one of the limitation that is used in the XML. That is one of the criteria that is used in the XML. That limitation will be removed by using the criteria, by using the content that is used. So significant, or in spite of the disadvantage, XML representation has significant advantages. So there will be advantage also, and it is used to exchange the data between the organizations, and for storing the complex data, and for storing the natural data that is used in the database management system. Now, what are the various, we can say, the what are the various organization, that is how to store the complex structured information in files. Now, first point is the presence of the tags makes the message self-documenting, that is a schema needs to be consulted to undertake the meaning of the text. We can readily read the fragment above, for example. Second, the format of the document is not rigid. So whatever the document, whatever the format that is available of the document is not rigid. For example, if some sender adds additional information such as the tag last accessed during the, or noting the last date on which the account was accessed, the receiver of the XML data may simply ignore the tag. SD2 has a tag that is known as a unit of measure specified, which the first item does not have, and the tag is also required by the various volume that is used. Now, third point is XML also nested the structures. Uh, Third part is XML also allows the nested structure, that is there is also nested structure that is also used in the XML. The purchase order that is shown in the 23.3, this is the 23.3 that is used. Whatever the purchase order that is used, that is the purchaser, there are different names and the addresses of the purchasers that is used. So that illustrates the benefit of having a nested structure, that is one structure will be used within the another structure, and each purchase order has a purchaser and the list of items as two of its nested structure. So whatever the nested structure, whatever the content that is used, that is available in the nested form, that is one in the another form. Each item in turn has an item identifier, description and a price nested within it. So every item has a identifier, that is a unique identifier, that is a IID, that is a item identifier, description, and the whatever the price that is also available, that is also nested within it. While the purchaser has a name and the address that is nested within it. Like this one, as we already see, there is item, there is identifier, quantity, quality, price, then there is a purchase order, there is a purchaser, then the name and the address. So name and the address of the purchaser, and the quality, quantity, and the price of the item, and as well as item identification. So finally, the XML is widely accepted, and wide variety of tools are available to assist in its processing. That is, there are many tools that is available in the XML that is widely used, that is also available in the processing. That includes the programming languages also, that also includes the API, that is the application programming interface, to create and read the XML data, browser software and database too. So it also includes the programming languages, that is XML also includes the programming languages like the API, that is the application programming interface. We describe several applications for XML data later, that is in section 23.7. Just as the SQL is a dominant knowledge or language, or dominant language for querying the relational data, in the same way as XML has become the dominant format for the data exchange. So SQL is a language or dominant language, or the important language for querying the relational data, while the XML has become the dominant format for data exchange, that is how to exchange the data that is available, that is provided by the XML. Then, what is the structure of the XML data? That is the next topic. That is how to use the XML data, or what is the main syntax of the XML data. So the fundamental construct in an XML document is the element. So that is the main content, that is the main form, that is we can say the main element or the main construct that is used in the XML document is the element. So the main element or the main content is the element. An element is simply a pair of matching start and the end tags. That is, there will be a starting tag, there will be an ending tag, and in between any content is available, that is known as the element. And all the text that appears between them, so that is, it also includes every text that is available in that content, that is the XML data. XML documents must have a single root element that encompasses other elements, all other elements in the document. For example, in the example in figure 23.1, the university element forms a root element, or forms a root class. So whatever element, whatever the content that is available, that is a university example, that contains a root element. Further, Elements in an XML document must nest properly. So whatever the XML document, whatever the element that is available in the XML document, that must be nested in a proper way, that must be nested in a proper manner. For example, this is the course, then there will be a title, then the title will be closed, then the course will be closed. So first of all, there is a title tag, a course tag, then this course will be closed, and in between title tag, in between the course tag, there is a title tag, and the title is given in this one, and that is properly nested. Whereas the course ID, that is the title, course ID title, that is also not properly nested. Why this is not properly nested? Because first of all, this will be opened, then this will be available, then this will be closed, then this will be closed. That is not a format. But the first tag that is opened, this will be closed at the end. In between there is a title tag. This is a proper nested, and this is not proper nested. While proper nesting is an intuitive property, we may define it formally. Text is said to be appear in the context of an element if it appears between the start tag and the ending tag. So there are two tags that is available, that is the starting tag as the ending tag, and data elements or the tags are elements or the text is available between the two. For example, if I want to give any title, the title will be represented, the title will be given within the tags, within the opening tag and the closing tag. And note that the text may be mixed with the sub-elements of an element. For example, in the figure 23.4, as with other several features of the XML, this freedom makes also make sense in the document processing system. That is how to use a document processing system, or how to make the document processing system content than in the data processing content, and is not particularly used for that for representing the more structured data such as the database content in the XML. The ability to nest the elements within the other elements provided an alternative way to represent the information. So whenever we nest any element, whenever we nest with the other element, whenever we combine the various elements together, that is also an alternative way to represent the information. In figure 23.5 shows a representation of the part of the university information from figure 23.1. But with the course element nested within the department cell element, that is also available, that is also used or used as a fetch to the document or course element. The nested representation makes it easy to find all the courses that is offered by the department. So whatever the course that is available, that will be identified by using the nested representation, because every course is available one after the another. So it is easy to find all the courses that is offered by the organization or the department. Similarly, the identifiers of the course that is stored by the instructor are also nested within the instructor element. And if the instructor teaches more than one course, then there will be a multiple course ID. That is a multiple course ID that is also available. That is also available with the corresponding instructor element. So instructor element and the document title is available within the two branches or the course ID. So this is the one of the example, that is a course. Then this is the name of the course, that is this course is being offered for the first time in 2009. Then there will be a course ID, then there is the title of the course, that is a computational biology, then department name to which the courses belongs. Then there will be credit, that is a 3, then the course will be closed. So this is the one part, that is a mixture of the text with the sub elements. Then university 1, that also again created the department, then department name, then building budget, then course, then CS 101, then credit, then the 4. That means this credit force means this will create, or this will take the 4 we can say the 4 copies of the available, 4 copies of the data that is available. And details of the instructor, that is a brand and the click, are omitted from the 23.5 for the lack of the space, but a similar instruction for the Srinivasan. This is the department name, this is the tailor, then course ID, then course ID, then course ID, this one, then title, then again the credit that is given, that is a 3, and details of the instructor, that is the brand and the click, are omitted from the 23.5 due to the space problem, due to the energy problem. And this is again the department. There will be a department, then there another department will be opened, at the biology department, and the building name is Betson, and the budget is 90,000, and the course will be the course ID is bio series 01, then the light title is genetics, then the credit is 4. Then again the instructor, then IDs or the item ID is this one, that is a 10101, then the name, department name, salary and the course ID. Although nested representation are natural in XML, then they may need to represent or retain the storage of the data. Suppose details of the courses that is stored by the instructor are stored and nested within the instructor table, instructor element as follows, as shown in 23.6. So that is whenever we use the XML documents, or we can say the nested document that is also available in the XML naturally, then we need to redundant duplicate the redundant storage of data, because data is available in the XML, also data is available in the data representation or mixing of the data. For example, this is the example that is given. If course is stored by more than one instructor, then the course information such as the department or the title, department who will be stored redundantly with very application associated with the data. Then this is the next example, that is a University 2 example. This is the instructor that is given, then there will be ID of the instructor that is used, the name, department name, salary, then teaches, that is a teaches the another sentence, or we can say the another tag that is used, then there will be a course, then course ID, title, department name and the credit value. So nested representation are widely used in XML data interchange application to avoid the joins. For example, a purchaser order would store the full address of the sender and the receiver redundantly, that the full address of the sender and the receiver is available in the redundantly on the multiple purchase order, because and the order or the address is same, but the address is written on the every purchase order that is available in the database management system. Whereas a normalized representation may require a join of purchase order or join of purchase order records with the company address relation to get the address information. In addition to the elements, XML specifies the notion of the attribute. And in addition to the element, XML also specifies the notion of the attribute. For example, the course identifiers of a course can be represented as the attribute, as shown in figure 23.7. So sometimes they also specify the notation of the attribute. The attribute of an element appear as a name value. So whatever the value, whatever the name that is available, that will be used as a two pair, that is a name equals to value before the closing tag. So whatever the closing tag that is used, there will be attribute that is available within the opening tag that is used. For example, if I want to use after the right angle bracket or the left angle bracket, there is a P, and after P there is a name equals to value pair that is available within the closing tag, that is available before the closing of the tag, before the closing of the right angle bracket. Attributes are strings and do not contain markup. Further, more attributes can appear only once in a given tag, unlike some elements which may be repeated. This is one of the example of the attribute that is given. There is a course, there is a course ID, then introduction, title, then department name, then credits, that is a 4 value, and the course will be closed. Note that in a document construction content, or whatever the document content that is available, there is a differentiate between the supplement and the attribute is very important. That is, there is a difference between the supplement and the attribute name that is used in the database management system. So attribute is implicitly text that does not appear in the printed or the display document. So whatever the document that is available, that is not printed in this one, but there are the features of an entity. For example, if I am giving the entity name is teacher or the teaches, so the where the various attribute, whatever the content that is available in the various attributes. So in a document construction content, there is a differentiate between the supplement or the, or we can say the supplement and the attribute is very important. Attribute is implicitly text that does not include, does not take in the document, that does not take the value of the document. This restriction is less relevant and the choice of representing data as an attribute or a supplement is frequently arbitrary. In general, it is advisable to use the attributes only to represent the identifier. So whenever I want to identify something, that will be used to identify by using the concept of the attributes. One final syntactic note is that element of the form element that contain no sub-element or the text can be derived from the element abbreviation. And since XML documents are designed to be exchanged between the applications, so our namespace mechanism has been introduced to allow the organization to specify a global unique name that is to be used as an element tags in the document. So there will be a global unique name that is available. There is a global identifier that is available in the Google, that is available to all the sites, that will be used uh, for making the XML constant or for making the data exchange between the XML or between the documents over the internet also or without internet, that will also be used. Therefore, for example, if Yale University wanted to business partner XML document, then it would be present a unique identifier to with a colon to each tag's name. This is one of the example, that is a yale.edu. And the department or the document that can have a more than one namespace declared as a part of the root element. And there are different elements that is associated with the different document that is with the different namespaces. Sometimes we need to store the value that contains the tags, however, without having the tags interpreted as the XML tags. This is the C data, that this is the course ID. Now this is the university, then there will be XLMS, that is Yale equals to http yale.edu. Then this is the, we can say, the information about the Yale and the course, that is a Yale course. Then there will be a Yale course ID, then title, then department name and the credits, then university. And then the unique tag names are assigned by using the namespaces. This is one of the example. This is the name of this diagram, or we can say this program. And documents, or because it is enclosed with the C data, the text course is treated as a normal text data, not a tag. And the C tag is used for the character data. Now next is XML document schema. That is, what is XML document schema, how to use the XML document schema. Before this, let's take a break, then move to this topic, that is XML document schema. So let's take a break right now. So come back from the break. Now let's start the session again. So next part is XML document schema, that is how to use the XML document schema and what is the main procedure is in the XML document schema. So XML document schema, that is the XML have a database schema, or the XML have a schema that is used to constrain what information can be stored in the database and when constrain the data type of the stored information, that is what is the information that is stored in the information or that is stored in the database, and what are the various constraints or what type of constraint that the database or that the database have stored information. In contrast, by default XML documents that have been created without any associated schema, an element may have sub elements or the attribute. So whatever the element, whatever the attribute that is available in the XML documents. While such freedom may occasionally be acceptable given the self-describing nature of the data format, it is not generally useful when XML document cannot be processed automatically. So whenever the XML document must be processed automatically, that is available as a part of the application, or even when the large amount of related data are to be formatted in the XML. So whatever the data application, whatever the data that is available in the XML, that is also available in the database formats. Here we describe the schema definition language that is included as a part of the XML document XML standard, that is whatever the data definition, whatever the schema, whatever the definition language that is available as a part of the XML standard document type definition, as well as its more recently defined replacement XML schema. Another XML schema definition language known as the relax and ng is also in the use, but we do not cover it here. For more information on the relax ng, see the references that is available in the bibliographic notes. So whatever the XML document, whatever the data that is available in the XML document, that must be prepared as schema, that must be available in the schema, that must be used in geographical, or we can say the XML documents. Now document type definition, that is what is the main document type of, we can say what is the main type of the document that is available of the XML, that is a what is the type of the XML documents. So XML document that is available, so the XML document that is available, that is an optional part of the XML document. The definition is not mandatory in case of the XML document, that is a we can say the optional, that is a part of the XML document. The main purpose of the DTT is much like of the schema, that is the main purpose of the giving the definition is just like a schema, that is what are the various constraints, what are the types of information that is available in the document, that is what are the various schemas, what are the, we can say the constraint, what is the main structure that is available of the information that is available in the, that is present in the document. However, the DTT does not in fact constrain types in the sense of basic types like integer or the string, that is there will be a constraint that is also available. The DTT is that was in the fashion or in fact constraint type that is available in the basic data type that is used in the we can say the integer or the string. Instead, it constrains only the appearance of the sub elements and the attribute within the element, that is what are the various sub element, what are the various attribute that is available in the sub element that is available in the element. The DTT is a primary list of rules for which a pattern of the sub rules or the sub elements are divided or that may appear within the element. Figure 23.9 shows a part of the DTT or example of the DTT for a university example. This is example of the data definition or document type definition that is used. Each declaration in the form of the regular expression for the sub element that is available of an expression. Therefore, in the DTT in figure 29.9, the university element consists of the two elements, consists of one or more course, that is the department or the instructor element that is used in the database schema, that have a multiple schema, and the operator that is used that specifies the OR. So that is the operator, that is a pipe symbol is used that specifies the OR condition. So this is the doc type university. This is the doc type that is used. Then this is a university, that this is the element, that is the university, and there are multiple, we can say the OR, that is either uses the department, either uses the course, either uses the instructor, either uses the teacher. So there are four elements that is used, that is either uses this one or this one. Then there will be element, that is a department, then there will be a department name, then there will be a building, then there will be a budget. So that is also used, that is either the department, that either the department name, either the budget, that is also used in this one. So then there will be a course, then there will be an instructor, then there will be a teaches that is also used. That is a teaches is also a department that is also available in the multiple data. Then there will be a department name, then there will be a building, then budget that is also used for budgeting the content, that is also used for the how to use the budget, that is also used for the various content. Then there will be a department name, then this is the building, that is the PC data, then there will be a budget, then will be a course ID, then there will be a title, credits, we can say the ID, IID, then there will be a name and the salary. And this is the example of the data term definition. We can say the document type definition. So this is the example, and the plus operator that is used, that specifies the one or the more. So if I add the plus operator, that means we can say it is more than one, that is a plus operator. Although not shown here, the asterisk operator is used to specify 0 or more. This is not shown over here, but the meaning of asterisk is 0 or more. The plus means 1 or more, and the 0 star means 0 or more, while the operator, that is a question mark, used to specify an optional element, or the optional element, that is a 0 or 1, that is either use the 0 or either use the 1. The course element contains sub-element, that is the course ID, title, department name, and the credits. Similarly, the department and the instructor have the attributes of their relational schema that is defined as the sub-elements in the DTD, that is the document term definition, or the document type definition. Finally, the element course ID, department name, credit, building, budget ID, and the salary are declared as a part of the PC data. That is, they are also available as a PC data, that is used in the PC data, that is used in the content that is available in the PC data. And the allowable attributes, or whatever the attribute that is also declared in the DTD, that is the document type definition, and the sub elements is also used, that also specifies the C data ID reference, that is also used for the C data. And this is the list, that is the course ID, that is the attribute have different definition, declaration, that is also the required fields. And this is the document type definition, document type document that have a IDRF attribute names. This is another example of the ID, that is the XML with the ID and the IDRF examples. Now next is the XML schema, that is how to use the XML schema. What is the use of the XML schema? So what is the XML schema? That is what is the schema? First of all, that is we can say the schema, that means the boundary, that means the structure, that is a schema. So now the XML schema, so an effort to redress the deficiencies of the document type definition, that is also used. So one of the effort to redress the deficiencies of the document type definition mechanism, that is how to avoid the we can say the limitations or the loopholes of the document type definition schema, that must be resulted in the development of the more sophisticated schema language, that is a XML schema. So whenever there will be a efficiency or deficiency, that is a limitation that is occurred or that occurs in the DTD, that is the document type definition, so that results in the development of more interesting schema language, that is known as the XML schema. We provide a brief overview of the XML schema, then we list some areas in which we can improve the DTD, that is the document type definition. So now let's see what is the XML schema. So that defines a number of built-in type with such as string, integer, decimal, date, and the boolean. So it defines a, or XML schema have a multiple or built-in the data type that is also used. In addition, it also allows user-defined types. These may be a simple types with added restrictions, or the complex type that is constructed using the constructor, such as the complex type and the sequence. Figure 23.12 and the 23.13 shows how to use the schema, or what are the various schema that is used in the database management system that is used in the DTB, that is a complex type that is constructed using the constructor such as the complex type and the sequence. And these are the two figures that shows how to use a DTD that can be categorized by the XML schema. The first thing to note about the schema definition is the XML schema are themselves specified in the XML analysis or syntax. So whenever we use the XML schema, that will be enclosed, that will be declared, that will be using the XML syntax, the XML schema that is also used in the XML format. That contains variety of tags or the tags that is defined by the XML schema. And to avoid the conflict with the user-defined tags, we prefix the XML schema tag with the namespace prefix XX. So whenever we use the XML schema, so the prefix or the keyword that is used is the X and the S. And this prefix is extracted with the XML schema namespace by the XML NS XML specification in the root element. So this is the target that is used, that is the XS schema, then XML NS XS equals to, this is the path that is also used for the XML schema. Note that any namespace prefix could be used in place of the XX that we use to replace, or that we could use replace the occurrence of the XS in the schema definition with the XX or XSD. So we can either use the XS or either use the XSD without changing the meaning of the schema definition. All types that is defined by the XML schema must be prefixed by its namespace prefix. So we can either use the namespace prefix, we can either use the XS. This is one of the example that is used, that is XS schema, that is the XML NS, that is this is the path, then this is the element name, that is the university, then this is the type, that is the university type, then element name equals to department, that is a complex type, then sequence that is also used, and the type of department that is also defined to be a complex type, which is further specifies to consist of the sequence of the element, that is the department name, building and the budget. Any type that has either the attribute or the nested sub element must be specified to be a complex type. Alternatively, the type of the element that can be specified to a predefined type by the attribute type. Observe that how the XML schema can be used by using the XS string, by using the XS definition or decimal that are used to constrain the type of the data element that is used in the database management system, such as the department name and the credit. Now this is one of the definition, one of the example that is used, that is the teaches, then complex type, then sequence will be closed, then complex type will be closed. And the attributes are also specified using the XS attribute tag. So this is the attribute tag that is used, that is the name equals to department name. So the name of the attribute, the name of the schema, the name of the attribute that is given is the department name. For example, we could have defined department name as an attribute by adding this one, that is the XS attribute, that is the name equals to department name, that is the name that is given of the department is the department name within the declaration of the department element, and adding the attribute, that is the use equals to required to the above attribute specification also declared that the attribute must be specified, that is the attribute must be specified, whereas the default value of the use is optional. And we can also use the XS complex type to create a name complex type. The syntax is the same as used for the XS complex type element that is also available in the database schema, except that we can add an attribute, that is a name equals to type name, to the XS complex type element, where the type name is the name we wish to give to the type, that is what is the type name that is also you wish to give to the name. In addition to defining the type, our relational schema specifies the specification of the constraint, that is whatever the constraint that is used, that must be specified by the database schema. And so XML schema also offers the several benefits of other DTD, that is the document type definition, that is also the benefit and is widely used in the day-to-day scenarios. So what's the benefits? Let's see. Among the benefits that we have seen in the example shown above are there. The first example, or the first benefit that is available is it allows the text that appears in the elements that to be constrained to a specific type. So whatever the data, whatever the text that we use, that allows the text, or the XML schema allows the text that appears in the element to be constrained to the specified type. So whatever the type, whatever the constraint that is available in the specific type, such as the numeric types in the special format or the specific format, or the complex types such as the sequences of the elements of other types. Then it also allows the user-defined types to be created. So whatever the user-defined type that is used, that is also created in the XML documents. Then it also allows the uniqueness and the foreign key constraints. So XML also allows the uniqueness, that is we can say the primary key attribute and the foreign key constraints. And next, it is integrated, that is the XML is also integrated with the namespace. So we can also use the namespace within the XML schema within the XML document to allow different parts of the document to conform to the different schema. In addition to the features we have seen, XML schema supports several other features that DTD do not provide. That is such as these features. It allows the type to be restricted to create specialized type, for example, by specifying the minimum and the maximum value. So we can also specify the minimum and the maximum value that is also restricted or also used as a specified or specialized type. It allows the complex type to be extended by using a form of the inheritance. Then our description of XML schema is just an overview. To learn more about the XML schema, see the references in the bibliographic notes. Now the next is querying and the transformation. That is the next topic, that is querying and the transformation. So given the increasing number of applications that use XML to exchange, mediate, and store the data, tools for the effective management of XML are also becoming increasingly important. So whatever the tool, whatever the effective management, whatever the content that will be used, that is a effective management of the XML, that is more increasing important. So whatever the application, whatever the content, whatever the effective management of the XML, that is most important. In particular, tools for the querying and the transformation of XML data are essential to extract the data. So that is very essential to extract the data. That is how to extract the data. What is the data definition that is used in the database management system? In particular, tools for querying and transformation of XML data are essential to extract the information from the large bodies of the XML data. So whatever the query, whatever the data that will be available, that will be querying, that will be used in the database management system. Just as the output of the relational query is a relation, the output of the XML query can be XML document. So whenever we use a relational query, the output is always a table, that is a relation. So and whatever the XML query we are using, the output can be XML document. As a result, querying and transformation can be combined to the single tool. So whatever the query, whatever the transformation that can be combined to a single tool. In this section, we describe the XPath and the XQuery languages. So there are two languages in this section. We define the two languages, that is the XPath language and the XQuery languages. So XPath is a language for the path expressions and is actually a building block for the XQuery. So this is a language, or this provides a path that over which the building blocks of the XQuery, or we can say that it's actually a building blocks for the XQuery. XQuery is a standard language for the querying the XML data. It is modeled after the SQuery but is significantly different. So it is significantly different for the XQuery that is also used for the defining the database management system. It is modeled SQL but is significantly different. Since it has to deal with the nested XML data, XQuery also incorporates the XPath expression. So whatever the XPath expression that will be used, that is also covered in the XQuery document. The XSLT language is another language that is designed for transforming XML. That is a language that is used to transform the designing, or that is also used to transform the XML document. However, it is used primarily in the document formatting applications rather than in the data management applications. So we do not discuss in this chapter. The tools, or the tool section that at the end of this chapter provides the references to the software that can be used or that can be defined, the how to execute the query that is written in the XPath and the XQuery. Next is the tree model of the XML. That is a tree model means there are different nodes, there are different paths that is available in the tree model. That is, there are nodes and the different path. Now XPath that defines or that enters the part of the HTML document by means of the path expression. So whatever the path expression that is given, that is also available, that is also, we can say, that is also part of the XML document that is provided by means of the path expression. The language can be viewed as an extension of the simple path expression in object-oriented and the object relation database. And the path expression in the XPath is a sequence of the location steps that is separated by the slash. instead of the dot operator. So the path expression, whenever we give the path, that is separated by the various slashes, that is available, that is separated by the slash. For example, on the document that is given in the figure 23.1, the path expression that is given in University 3 instructor name. The expression that is a University 3 instructor name text that returns the same names but without the enclosing tags. Path expressions are evaluated from the left to right. So these are evaluated from the left to the right. Like a directory hierarchy, the initial slash indicates the root of the document. Note that this is an abstract truth above University 3, that is the document tag. As a path expression is evaluated, the result of the path at any point consists of the order set of the nodes. So whatever the content, whatever the data that will be available, that will be available in the content of the database management system. So as a path expression is evaluated, the result of the path that is also available as a mode as a nodes from the document. This is a University 3 example that is also given in this example, that returns a single path that corresponds to the University 3. Whatever the result that is available for the path expression, that is also represented, that is also used as set of node, that is also used as the last step of the path expression. And XPath also supports a number of features. So first feature is, whenever we use the selection predicate that may follow any step in a path that is contained in the square bracket. So whatever the path, whatever the square bracket that is given, that is used as a path and contained in the square bracket. So that is the credit is less than or more than greater or equals to 4, that is the square bracket. So this returns the course identifier of these courses that is also available in the course path. So there will be a selection bracket that is also used in this one, that is also used for defining the term, that is also used for the XML document, that may contain a sequence in the steps that is also contained in the square bracket. So this returns the course elements that with the credit value that is greater than or equals to 4. So this gives the course element that is available that have a course value that is greater than or equals to the 4, while the University 3 course credit is greater than equals to 4 at the rate course ID, that returns the course identifier of this course. So whatever the course identifier that is used, that is available in this course. So we can test the existence of the sub element by listing it without any comparison, without any error. For example, if we remove just greater than equals to 4 from the above, we use the expression, there will be a expression that will return the course identifier, all those courses that have a credit supplement regardless of its value. So if I remove this one, that means there is no credit value, so it can be increased or it can give every credit value that is available in this one. The next point is XPath provides several functions that can be used as a part of the predicate. So whatever the part, whatever the document that will be used, so this provides the predicate or this provides the function that can be used as a part of the predicate, including the testing of the position of the current node. That is, what is the current node, what is the main target of the current node, how it will be used, and what is the main criteria of the current node. And the function ID, that is the foo, returns a node with an attribute of type 2 and the value foo. So the type has a value, the type has a ID, and the value is the foo. That can be even be used as a reference, that can be used as a IDRF. For example, this is the path that is used. Then the operator, that is a pipe operator that allows the expression result to be. So but expression result, whatever we can say the operator that is used as the pipe result that allows the expression result to be union. For example, given data using the scheme from figure 23.11, we could find the union of a computer science and the biology courses using the expression. There's the computer science and the biology department. Then the XPath expression can skip multiple levels of nodes by using the double slash. Then a step in the path need node B or need node just select from the child of the children of the nodes in the current node set. And it is one of the several directions that is also used in the path that may be processed as the parent, sibling, and the descendants. Then the built-in function that the document name returns the root of the name document, that is the names could be a file name or the URL. For example, if the university data in our university example is contained in the file that is university.xml, the following path expression would return all the documents, all the departments at the university, that is the doc university.xml university department. And the collection function, that is a collection that is also similar to the doc function, that must be returned or that must return a document type that is identified by the name. In most of our example, we assume that the expressions are evaluated in the context of a database that improves the that implicitly provides a collection of the documents on which the XPath expressions are evaluated. In such cases, we do not need to use the function that is the doc and the collection. Next is the sQuery, that is the xquery, that the www consortium, that is W3 consortium, that is also used, is developed the xquery as a standard query language. So this used the xquery, or this developed the xquery as a standard query language for the XML. Our discussion is based on the xquery 1.0, which was released as a W3C consortium on the 23rd June or 23rd January 2010. So that is the www consortium, that is also used as a or also recommended on the 23rd June 2007. Then the first one in this expression in this query is the FLWR expression, that is a FLWR expression, that is a for, let, where, order by, return. These are the 5 expressions that is also used in the XML query, that is a for, then there will be let, then there will be where, then there will be order by, then there will be return. They are also referred to a floor, or we can also say the flower expression with the letters in the flower denoting the 5 sections. A simple FLWR expression that returns the course identifier of the courses with the greater than the 3 credits, that is also the XML document that uses the ID and the ID or IDREFS. And this is one of the example of the flowers, and these are the various syntaxes that is used in the flowers. For example, this is for X in the university 3, then course, then return course ID and the course name. This is the return, then there will be the course ID that is also used, then there will be course ID that is also used in this one. Then next is the joins, that is also specified in the xquery as they use in the SQL. Can also be used in the xquery as also used in the SQL. The joins of course instructor and the teacher is expressed in the 23.1. Now next is a nested query, that is how to use the nested query, that is the one query within the another query, that is a nested query that can be nested in the return clause in order to generate element nesting that do not appear in the source document. For example, an XML document, XML structure that will contain or that course element contains, that will nested in the document that would available within the department that can be generated from the structure. Then next is the sorting of result, that is how to sort the result by using the order by clause. Then what are the various functions? The same as we do in the SQL, that is these are the various functions. For example, declare the function first of all, then use the for $i in the university, that is also used for the expressions. Then other feature that is also used, that the return classes, essential, university quantification, that is also used as a predicate values. Now next is the application program interfaces to the XML. That is the next topic that I'm going to start in the next class, that is in the tomorrow's class. So this is the topic, that is how to use the application program interface, or how to denote the application program interfaces to the XML. So this I'm going to take in the next class, that is in the tomorrow's class. All right. So thanks a lot everyone for listening me. If there is any doubts, any query, you can ask the doubts from me. So in the tomorrow's class, I am taking your next topic, that is application program interface to the XML. So that's all for today's session. Thank you so much. Bye bye everyone. Hello. Yes, Joseph. Tell me the query. Good afternoon. How are you? I'm also good. Thanks. Ye- ye- yes. Tell me. Hmm. Hmm. Just a minute. I will open it. Which computer system assignment? E-commerce. Just a minute. Have you got the computer system assignment? Okay, just a minute. I will check it. E-commerce assignment. Just a minute. Mm-mm-mm. This assignment. Yeah, this is the e-commerce assignment. Are you able to see my screen? This asks student to evaluate each other models and give the comment. That is, what are the various models that is used in this one? That is, what are the various scenarios? That is, what are the various other models except the e-commerce? Ye- Yes. Other models means other criteria that is used to achieve the target. Yes, tell me. Hmm. Hmm. What method do you apply for making the e-commerce as an online model? So design a model or write a theory, that is how to make the online transaction, how to make the e-commerce, that is a electronic commerce, how to make the possible or how to make the commerce possible, that is a e-commerce. So I will upload the assignment tomorrow in the LMS also, right? No, I'm not sure about that. I will confirm you on tomorrow. That is tomorrow. All right. Bye bye. Welcome. Bye bye.